Another session for the FOA, the Fetchers of America. Welcome back. We're going to talk today about the multiplication of polynomials. I think this is a pretty understandable concept, okay? Watch this video. Watch it thoroughly. You should do super well on the homework. First thing we got to understand is multiplication of polynomials comes in four types, okay? And what we're going to write here is that the four types are what we call mono times mono, mono times any poly. Then we'll have the bi times the bi, and then the any poly times any poly. And we're going to go through all four of these in our lecture over multiplication of polynomials. So all four of those, 1, 2, 3, 4. So I'm going to erase that. And we're going to start with the mono times the mono, and you'll understand more about what each of these mean. I got to say, Alex cleaned these boards. This boy can clean boards. These are smooth. He's going to be a good diaper changer someday. I mean, baby butt smooth, you know what I'm saying? All right, so number one, the monomial times the monomial. We just call it, like we say, we call it polynomials polys for short, so we just call the monomial times the monomial, the mono times the mono. And the key principle you have to understand here is that we want numbers to go with numbers. And we talk about that. We're talking about big numbers with big numbers. And we want x's to go with x's, and we want y's to go with y's, and we could hit etc., etc. Now, what does this mean? If I have 2x squared y, okay, how many terms are in that expression? Yeah, one. There's no plus or minus signs between these big numbers and these variables, and so that's one term, so it's a monomial. And if I have another parentheses here, and these two parentheses, what are they doing? They're kissing each other, right? And if two parentheses are kissing each other like that, and there's nothing written in between, what do we always know is taking place? That's right, multiplication. And so inside this parentheses, if I have -4, x, y to the third, okay? The thing you got to understand right now is, we're not adding these. These are not like terms. Okay, I want you to see the difference here. If I had 2x squared y plus, and we could put -4xy to the third, that would be the addition of, two terms. And you can see the distinct difference there. There's nothing written in between here, so that's multiplication. In between these two, we have a plus. And are these like terms? No, they're not. So we can't even combine these, right? So it's kind of a moot point. So we're going to get rid of that, okay? These two are being multiplied. And again, how many terms here? One, monomial. How many terms here? One, monomial. Okay? Now some people say, well, there's a minus in between these. No, that's a negative that goes with this. There's nothing written in between the parentheses, so they are being multiplied. And when we say numbers with numbers, okay, what this means is, and before I tell you what it means, I want to remind you of a really cool concept that we learned, what is this, March? At least 6 weeks ago, almost 2 months ago, about the commutative law. Remember, to commute means to what? It means to move from one place to another. And so, look at this. If I have 2 times 4 times 3, okay, let's multiply that. 2 times 4 is 8, right? 8 times 3 is 24. Very good. Does that equal 3 times 2 times 4? Same three numbers, just in a different order. 3 times 2 is 6 times 4 is 24. Yes, we learned that when everything's being multiplied, I can rearrange it and it remains the same. Yeah, exactly. So let's think about this. What's going on between the 2 and the x squared right there? Nothing. Again, multiplication. What's going on between x squared and y? Nothing. Again, multiplication. What's going on between the parentheses? Again, nothing. Multiplication. Between -4 and x, nothing. Multiplication. Between x and y to the third, nothing. Multiplication. It's all multiplication, which means we can rearrange things just like we can rearrange them here, and it remains the same. So what we're going to do is we're going to put numbers, big numbers with big numbers. 2 times -4 X's with X's, X squared times X, and Y's with Y, Y times Y to the third. Now let's think about that. We've got the 2 and the -4 right there. We got the X squared and the X right there. We got the Y and the Y to the third right there. And everything's still being multiplied, but now the numbers make -8. X squared times X, this is why we learned our laws of exponents, right? Everything builds on itself in math. These have the same base, X and X, this is to the power 2, this is power of 1, and the product rule says we can add those. 2 plus 1 is 3, so we have X to the third. This is X to the 2 plus 1, right? And this is Y to the 1 times Y to the third, and that is Y to the 1 plus 3, which makes Y to the fourth. And that's our answer. That's our answer right there. And that's how we multiply a monomial times a monomial. Okay, super simple. And everything else, so we said there's 4 types of multiplication of polynomials. All the others build on this. If you understand this, then you understand how to do the other 3. We're going to teach you about that in a moment. Let's go ahead and pause for just a second. Okay, so what we want to do now is give you an opportunity to practice a few sample problems. Just so you know, this is number 6, 8, and 14 from your homework. So if you do these and you tag them onto your homework, you get an extra point per problem. So it's just a way that you can double up your efforts, learn and get some extra credit today if you turn them in with your homework, showing your work and all that. I'm going to show you that this problem right here is more complex than anything you're going to see in the homework tonight, but I want you to understand this concept. I love that we have multiple variables in here, and we're going to get to that later in section 4.7, but in tonight, or today, we're going to have 4.5, you're going to be good. So here's 3 different examples, okay? So this is 1, okay, this is 2, and this is 3. So I want you to, right now, and we're not going to pause, but I would recommend that you hit pause. Whenever we have examples, I hit pause, I practice these. We're going to go through and show you how to do these now, and hopefully you've done them on your own. So remember, numbers with numbers, we have 10 times 2. A's with A's, A squared. 10 times 2 makes 20. A squared times A squared makes A to the 2 plus 2, which is A to the 4th. Hopefully you got that right. Say woo if you got it right. Say woo if you got it right. Yeah, if you're at home and you said woo right now, and your roommates are like, what the fetch? You just tell them, man, I'm doing math, dude. I'm a wooer when I do math. Okay, again, numbers with numbers, 0.3 times negative 0.8. You put that in a calculator, you're going to get negative 2.4. Okay? Actually, are you? I don't know. You might have to check that for me, Alex, real quick. It might be negative 0.24. I'm kind of tired of a long day here. And x's with x's, x to the 4th times x to the 6th. And again, that makes x to the 4 plus 6, right? X to the 4 plus 6, which makes x to the 10th. Okay, so 0.3 times negative 0.8, yeah, it's negative 2.4, right?
Negative 0.24.
Oh, okay, see, it is, isn't it? It's negative 0.24.
Yeah.
X to the 10th, right? So there is your answer on that one. Put those in your calculator. See, obviously, Brother Rich didn't do it with a calculator. He got it wrong first, but I was kind of thinking I was wrong. But anyways, and then this one, people are like, whoa, Brother Rich, we got 3 monos, and this is just called mono times mono. Well, it could be mono times mono times mono times mono times mono. Doesn't matter. All the numbers go together, because remember, everything's being multiplied, right? What's between here and here? Multiplication. Between here and here, multiplication. Here and here, multiplication. Here and here, multiplication. Here and here, multiplication. It's all being multiplied. So I can take the numbers, negative 2, 10, negative 3. I can take the y's, y to the 5th, y to the 4th, y to the 3rd. And so, again, a negative and a negative make a positive. 2 times 10 is 20, times 3 is 60. Y to the 5 plus 4 plus 3, this ends up being 60. Y to the 5 plus 4 is 9 plus 2 is 12. So you have 60 y to the 12. Okay, let's go ahead and pause. Good, okay. So the second type of multiplication of polynomials highlights what we call the monomial times any poly. And what that means is our first term is going to be a mono, and then this could be a bi, it could be a tri, it could be 4 plus terms, anything but a monomial, because we just learned what mono times mono does. So if we see something like negative 2x times x squared minus 5x plus 6, okay? How many terms are outside of the parentheses? 1. This is a monomial. And then you have this expression right here, it's a trinomial. You have a term, plus or minus a term, plus or minus a term. And so what we're going to teach you in this concept is the mono times any poly ends up being, so you have this mono times this term, plus or minus a term, plus or minus a term, dot, dot, dot. And we're saying then is this is going to go to here and here and here, etc., etc. And you're going to end up with this monomial times the term, which is another monomial really, plus a monomial times a term, plus a monomial times a term, dot, dot, dot. And we're going to write something here, and it says always, always plus in between. And that means that we're going to take the sign before the term with it. You're going to understand what that means up here in just a minute. So our monomial in this instance is negative 2x. And negative 2x has to go to here, and to here through multiplication. And so we have negative 2x times x squared. This is like when we learned the distributive property, and how to distribute parentheses. The negative 2x becomes the distributor, and then we have a polynomial of 3 terms, and every term in that parentheses has to receive the distributor. Just like in times past, when we have something simple like negative 2 times x plus 3, the negative 2 goes to this term and to this term. Negative 2 times x makes negative 2x. Negative 2 times 3 makes negative 6. So we brought it to each one. Same exact concept here, but we can use bigger terms than just x and 3. We can have terms that require us to understand the monomial times the monomial thing. So we end up with negative 2x times x squared. We write plus here. Why? Because Brother Rich said I'm always going to write plus there. And then this is going to be negative 2x. Notice how I didn't put a minus there. I took the negative with its term in that parentheses, and then the negative with this term inside of its parentheses. What do I write in between this mono times that term? A plus again. Negative 2x times the last term, 6. So what's fascinating here is if you understand how to multiply a monomial times a monomial, I told you, you understand how to do all the future multiplication of polynomial problems, because really this is 1 mono times mono plus 2 mono times mono plus a third mono times a mono, okay? And so what we just practiced, we get more practice of. Just triple the fun, right? Or you triple the pain. So again, numbers with numbers, we just have negative 2 times 1, okay, because that's a 1 in front of there. And so just it's negative 2. And x times x to the second makes x to the third, right? So, and ultimately we're saying negative 2 and x to the second. Those are already all together. You don't need to rewrite it. You can just put the answer down here. This one here, we have a negative 2 times a negative 5. Numbers with numbers, that makes positive 10. X times x, okay, again, that makes x to the second, right? Because we have a 1 and a 1 there. And then finally, we have plus, and a mono and mono, we have negative 2x, and we have 6. Numbers with numbers, negative 2 times 6, and x, we can rearrange all that, makes minus, so we can get rid of this now, minus 12x. Because now when we write the answer, we don't put a plus in between each thing. We just do that to begin the problem. And this is our final answer right here. That mono times that trinomial yields these 3 terms right here. Pretty cool. Okay, let's pause for a second. All right, so now it's example time with the mono times any poly. Remember we said a mono times any poly could be a mono times a bi. Here's a mono times a bi. Our first example that we've erased, and it was just a few seconds ago for you, was a mono times a tri. And then we have a mono times 4 terms. It could be times 5, 6, any amount of terms. As long as it's not mono times mono, then it would just be a mono times a mono. Okay, so again, our distributor here is this negative 4x squared. And it's got to go to here and to here, right? And so we end up here with negative 4x squared times x squared. What do I write right here? Always plus, says always plus in between the sign is going to go with the term inside of its parentheses. So we're going to end up with negative 4x squared times negative x in our second set there. So this went to here, and then this went to here. again, numbers with numbers, we really don't need to rewrite this. It's -4 times 1, x squared times x squared is x to the 4th. That one is really taken care of there. And again, remember, you have a mono times a mono. Again, learning, everything is just a further extension, more of the same. Monomials times monomials. You understand that singular concept? It just keeps repeating itself in bigger formations. This right here is a monomial times a monomial, and we end up with -4 times -1, and x squared times x, right? Because this is a -1 there. And -4 times -1 makes +4. And x squared times x makes x to the 3rd, because this is x to the 2 plus 1. So this right here is your answer. Let's go ahead and do this one real quick. Again, the monomial outside of the polynomial is -4x. It's going to here, to here, and to here, and to here. So you have 4 terms inside of there. You end up with 4 mono times monos. Think about that. Look, we had 1 term times 2 terms. 1 times 2 is 2. We have 1, 2 mono times monos. You have 1 term times 1, 2, 3, 4 terms. You can end up with 1 times 4 is 4. You're going to end up with 4 monomial times monomials, you know. And so we end up here with -4x times 2x to the 3rd plus, always plus in between, -4x times -6x squared plus, always plus in between, Brother Rich teaches me, -4x times -5x plus -4x, and I'm going old school here, where you draw to the edge of the paper and wrap it down like you did when you were in grade school or something. Kind of funny there, okay? Sorry about that. Remember, numbers with numbers. We have -4 and 2 and x to the 3rd, right? This makes -8x to the 1 plus 3 is x to the 4th. Very good. Okay, over here, we're going to end up with -4 and -6, x and x squared. -4 and -6 make a positive 24. X to the 1 plus 2 makes x to the 3rd. Over here, we have -4 and -5 and x and x. -4 times -5 and negative make a positive 20. X and x make x squared. And down here, we just have -4x times 1. Anything times 1 is itself. We just have -4x, and that is the answer to our problem, okay? So we have covered half of our knowledge about multiplication of polynomials. We're gonna just take a small pause. All right, so our next one is a fan favorite. It is our 3rd type of multiplication of polynomial, and it's the binomial times the binomial, which we will call the bi times the bi for short, just like we call monos monos and monomials monos and polynomials polys and all that. So the binomial times the binomial, okay? How many of you ever learned what we call the FOIL method? FOIL method, yeah? So I want you to think about this. FOIL, what does it stand for? F-O-I-L. Stands for first, outside, inside, and last. Okay, so if you've learned that, this is what we're talking about. But we're going to do it a little differently. It's still going to be exactly the same structure, and the answer is going to be exactly the same, but how we approach it and learn it is just a little bit different. So if I have a binomial, x plus 3, again, how many terms in this polynomial? 2, times another binomial. Again, what's written in between these? Nothing, so it's being multiplied. I have 2 terms here, 2 terms here. In other words, I have a bi times a bi. Okay, a binomial times a binomial. Makes sense, right? So here's the first concept that you need to understand. Everything in the first parentheses goes to everything in the second parentheses, all right? Everything in the first parentheses goes to everything in the second parentheses. And that means through multiplication. And again, we are going to pick up on what we did in the last one, where we're going to have a monomial times a term, plus a monomial times a term, dot, dot, dot. And this is always a plus in between the mono times the monos. Let's think about this for just a minute. How many terms again are here? 2. How many terms are here? 2. What's written in between? Multiplication. What's 2 times 2? 2 times 2. 4. That's right. So I would guess you're going to have 4 mono times monos. And again, we said everything we learned in that first thing about mono times mono is going to come back to us. So what does it mean everything in the first parentheses goes to everything in the second parentheses? If this x right here, that has to go to here and to here. Ultimately, we're saying we have x times x plus 7. Understood? X times this x plus 7. And then this 3 right here, it's got to go to everything over here. And so we're going to end up with, plus 3 times x plus 7. Now, you don't have to write this step right here, but I just want you to see this ends up being, if we just take this from here to here, we end up with x times x, always plus in between, x times x, plus x times 7. Okay, think about that. X times x times 7. Here is x times x times 7. And it just sometimes it helps to break it into these two, formations here. And then we're going to have plus 3 times x plus 3 times 7. Okay? And think about that. X times x times 7. X times x times 7. 3 times x, 3 times 7. 3 times x, 3 times 7. Or you could break it up this way just to see it a little bit clearer. Again, one mono times mono, a second mono times mono, a third mono times mono, a fourth mono times mono, right? And we said 2 times 2 will give us 4 mono times mono. It proves true. X times x is x squared. X times 7 is plus 7x. We don't write x7. Why don't we? We always put the coefficient up front. And one of the reasons we do is because this next one, plus 3 times x, it shows that these are like terms and we can combine them. There's no equal sign here. We're going to simplify this. If we can combine these terms, we're going to. 3 times 7 is plus 21. These middle terms combine. We get x squared plus 10x plus 21. And this is the third thing I just want to give you a little extra hint, okay? We'll call this a little extra hint, okay? The middle terms, all right, often, does often mean always? Obviously not. Always means always. Often means, a lot of the times, but not always. Middle terms often combine, okay, as was the case right here and here. Okay, so that's your final answer, x squared plus 10x plus 21. Before we do some examples, let's take just a minute. And let's talk about FOIL, okay? What does that mean? Okay, so a lot of you learn this acronym. I'm not a big fan of teaching with acronyms because I think acronyms sometimes make things way more confusing than you need them to be. Sometimes they help you memorize, but then what are you memorizing? First means the first term in each parentheses. The first term in each parentheses is an x and an x. X and an x. Now, you would think the outside term would then mean the outside in this parentheses and the outside in this parentheses, but they're actually talking about the whole configuration. The outside of this and the outside of this is x and 7. So you can see where it can start to get a little bit confusing. Plus, it doesn't tell you to put a plus in between there. This method just assumes you're going to do that. Plus, and then the inside terms in the whole thing are 3 and x. Okay? And the last terms in each parentheses are 3 and 7. Well, look at what we just did here. X and x, x and x. X and 7, x and 7. 3 and x, 3 and x, 3 and 7, 3 and 7. The FOIL method is everything in the first parentheses goes to everything in the second parentheses. They're the exact same thing. So if you learn FOIL and you know FOIL, that's awesome, okay? Now, it wouldn't be a multiplication of polynomial lecture if we didn't do the FOIL dance. Okay, so I want you right now, I want you to stand up wherever you're at, and if you don't do this, I will reach through this video and grab you by the neck and squeeze you until you pop. Okay, so come on, get up. You got to get up right. Get up. Come on. All right, you ready for this? Can you see my whole body in this video right now, Alex? Do you need to pop that off? Here. Come on. Yeah, there you go. Can you see me? Can you see me, man? Can you see me top to bottom here? Okay, everybody standing up? Okay, the first thing I want you to do is, I want you to sway. This is the palm tree. Sway. Okay, this is called the FOIL dance, right? So the first move is always a hip thrust to your left. First, okay? Right, you know where outside is. That's your derriere behind you. Outside, we know where inside is. Bring it forward. Inside, and then to the right for last. Now put it all together. First, outside, inside, last. First, outside, inside, last. Yeah, and you just got to know this, man. It's the FOIL dance. And so if you're taking a test and you can't remember what you're doing, just close your eyes and stand up and do the foil dance, okay? All right, enough with that. We are going to pause for just a second, reset our camera, and put some examples on the board. Okay, all right. Alex is killing it behind the camera. Here we go. So again, how do we know what we have here? We don't have a one term times a one term. That would be a mono times a mono. We don't have a mono times two terms, three terms, four terms. We have a bi times a bi, multiplication in between. A bi times a bi, multiplication in between. So we're going to take 2x, it goes to everything in the second parentheses. We're going to take plus 5, it goes to everything in the second parentheses. These parentheses are the same, it doesn't make a difference. Okay, 2x has to go to these two, 5 has to go to these two. Again, you could just write then, 2x times 2x. You can go straight from here to this step. You don't have to write this intermediate step if you don't want to. I do find this helpful for many people in keeping this organized and not losing a negative or something of that nature. I'm going to mix things up a little bit here today, and I'm going to write a minus, and I'm going to write a minus. I'm going to change this to a minus as well. And we're going to kind of scrap this and just say, hey, we're doing our own thing because I just want to get some better examples than some of the ones that are in the book, okay? So a 2x times a 2x plus 2x times negative 5, sign before the term goes with it, always write plus in between. 5 times 2x and plus 5 times negative 5, right? And so again, numbers with numbers, 2 times 2, x and x, we get 4x squared. Numbers with numbers, 2 and negative 5, x at the end, minus 10x. 5 and 2 numbers are already together is 10, and x is at the end, plus 10x. And, are we doing this right? I hope so. 2x times 2x, 2x times negative 5, 5 times 2x. Okay, and then we have 5 times negative 5, and I'm sorry, there's something amiss here for me. I feel like, yeah, right, okay, we're good. And then we have plus 5 times negative 5, and we know that is just going to be minus 25. We don't even have to mess with either one of these, we can just do them. Well, look what happened here. These two canceled each other out. This is an interesting phenomenon. One of the things it's going to say in your textbook and your homework, it's going to say on some of these, multiply mentally if possible, okay? That's just mental, okay? I never tell you to do stuff in your head. That's just dumb in math. You never just do stuff in your head. Now, I get that that's a cool skill to be able to do things without a calculator, without writing it down. But whenever you don't write it down, you seriously take a chance in getting something wrong. So I always want you to show your work. But when we have the exact same terms, 2x, 2x, 5, 5, but one is positive, one is negative, the middle terms always cancel out. Okay, kind of cool. We're left here with 4x squared minus 25 when we simplify this, okay? Let's do this one over here. We're going to end up with, now notice, these two terms, they're not going to cancel out because these two sets of terms are not identical, but one is plus, one is minus, but they're very different. And so we do this one, we're going to end up with, and this time I'm going to skip this middle step. You determine if you like this middle step or not. This time we won't do it. 3 times 6 plus 3 times negative 2x, right? 3 times 6, got to go to here, got to go to here. I do like drawing the arrows just to keep myself honest. Plus x and 6, keep myself organized, plus x and negative 2x. I have 1, 2, 3, 4 mono times monos. 3 times 6 is 18. 3 times negative 2x is negative 6x. X times 6, I do like to write 6x in that, okay? And then in this last one, I'm going to end up with negative 2 and x, and I get negative 2x squared. Look at this, really interesting. The middle terms canceled out, and people are like, I thought you just said, Brother Rich, that these are different. They won't cancel out. They won't always cancel out. And this one, if they're identical, they'll always cancel out in the middle. This one, it depends on what numbers you have. And so this happened to work out that these two did cancel out, and you ended up with 18 minus 2x squared for your final answer there, okay? Kind of some cool examples, all right? Let's do one more, just for kicks and giggles here. Let's do this really quick. X minus 5 times 2x minus 2, okay? Let's look at this super fast, okay? Let's do this together. X times 2x, right? x plus, always plus in between, x times negative 2, right? The x has to go to here and here. And then we'll have plus negative 5 times 2x, right? Because this is going to go to here, and then this is going to go to here. And so we'll have plus negative 5 times negative 2. Let's multiply them all out. Okay, we'll have a 2 and an x, so we get 2x squared. Over here, we're going to have minus 2x because we always put the number in front of the variable. Over here, negative 5 times 2 is going to be negative 10x. And down here, negative 5 times negative 2 is plus 10. My middle terms don't cancel out, but they surely do combine because they're like terms. Remember, at this point, we have 4 terms being separated by plus or minus signs. We combine our like terms. We end up here with 2x squared minus 12x plus 10, and that is your final answer. All right, you guys, we're going to put this on pause and go to our last method. Okay, all right, guys, so interesting here. Our fourth and final one, I'm just going to erase this, number 3, by times by. But I'm going to leave all this here because the directions are just the same. Any poly times any poly. And so what this means is we could have like examples. We could have a bi times a tri, or a tri times a bi. We could have a tri times a tri, etc., etc. You have 4 terms times 3 terms. And these just get bigger and bigger. And so, like, let's say that I have x squared minus 6 times 2x squared minus 5x plus 1. Okay, it's a 5 right there. Times 5x plus 1. All right? This is a binomial times a trinomial. All right? What's written in between these? Multiplication. So we know we're multiplying polynomials. How many terms here? 2. How many terms here? 3. What's 2 times 3? 6. You're going to end up with 6 mono times monos. Same thing. Everything in the first parentheses has to go to everything in the second parentheses. And we got to have this mono times mono plus mono times mono over and over again with the plus in between each one. And so this one, I kind of insist on taking x squared and saying, look, let's multiply x squared times this parentheses 2x squared minus 5x plus 1. The bi times the bi, I'm okay if you skip this step. In this one, it's really tough to stay organized if you don't. Always plus in between. And again, 2x squared minus 5x plus 1. Think about this. We just took x squared, right there, x squared, and multiplied it times this parentheses, and then negative 6, and multiplied it times this parentheses. You'll end up here with x squared times 2x squared plus x squared times negative 5x plus x squared times 1. Over here we'll have plus negative 6 times 2x squared plus negative 6 times negative 5x plus negative 6 times 1. If you ever see me make a mistake, Alex, catch me, okay? Keep an eye on it, yeah. Notice, again, a mono times a mono. A mono times a mono. Mono times mono, mono times mono, mono times mono, mono times mono. 1, 2, 3, 4, 5, 6, indeed. It's like the first thing we did, but 6 of them in one problem, okay? Listen, guys, this stuff isn't super hard, but this is all about being thorough and being organized. And so, you know, you don't need to get these problems wrong, but you've got to show your work and use lots of paper. We're using lots of board space here. There's no sense in saving a tree, okay? You know, the next generation, you know, they can starve with oxygen deprivation, but you will live and use a lot of paper. So let's look up here. X squared times 2x squared, numbers with numbers, right? 2 goes up front, I have x squared and x squared. This ends up being 2x to the 4th. Over here, I have negative 5x squared and x. This ends up being minus 5, x squared, x to the 2, x to the 1, makes x to the 3rd, right? X squared times 1, anything times 1 is itself, so that's plus x squared. We come on down here, we have numbers with numbers, negative 6 and 2, that makes negative 12x squared. Notice that these two are like terms. We're probably going to have a couple of like terms, maybe. Again, numbers are already with numbers. Negative 6 and negative 5 make positive 30 and x, and negative 6 and 1 makes negative 6. We look at this. We have x to the 4th. So we have 1, 2, 3, 4, 5, 6 terms. Do we have any other x to the 4th? Nope. That's coming down to the answer, 2x to the 4th. I'm going to cross that out. Do we have any other x to the 3rds? Nope. Okay, we look around. I'm going to cross that out. I have an x squared here, and I have a negative 12x squared there, which makes negative 11x squared when I combine those two. Then I have plus 30x, so we cross these out, and I have minus 6, and that's my final answer. These are a little bit more in depth. I'm going to put another problem on the board for you to do. We're going to take a quick pause. hold on.
Oh.
Times x minus y plus 1. Let's look at this. How many terms here? 3. How many terms here? 3. Multiplication, 3 times 3 is 9. 9 mono times monos. We're going to take this. We're going to take x and multiply it times x minus y plus 1, right? X times all this. Plus, and I'm going to just do this in a different colored pen just to kind of highlight y. So we're going to take y and we're going to multiply it times x minus y plus 1. That's the same thing there. And then we'll get one more colored pen and we're going to have, negative 1 and we're going to have, minus 1. And we talked about, let's put a plus in between each of these. So I like that idea. Let's go ahead and write plus negative 1 times x minus y plus 1. And I was supposed to do that in blue. And so I'm going to redo that. My bad. Just one more time, we'll say plus negative 1 times x minus y plus 1. Okay, so x times this parentheses, y times this parentheses, negative 1 times that parentheses. Okay, we're going to end up here with x times x plus x times negative y plus x times 1 plus y times x plus y times negative y. This is all this coming right here. All this is coming right there. And then plus y times 1. And then the blue is going to all be over here. We're going to have plus negative 1 times x plus negative 1 times negative y plus negative 1 times 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mono times monos, okay? Just trying to get you to see how all of this really just goes back to what we did before. I think drawing these little brackets helps kind of help you, isolate and segregate each of these specific mono times mono so you can do them accurately. X times x, we know that's x squared. X times negative y, remember the negative goes up front, that's negative xy. X times 1 is plus x. This gets really interesting right here. Are we going to write yx? Or are we going to write it xy? You're going to always put it in alphabetical order. Look at what happens. This xy and that xy are going to cancel each other out. If you had dropped that down and said yx, they wouldn't look like terms. So that's why you want to put the things in alphabetical order so you can see, these are like terms, okay? So we got 1, 2, 3, 4, here we go. Negative y squared. This is going to be plus y times 1 is plus y. Negative 1 times x is negative x. Negative 1 times negative y is positive y. Negative 1 times 1 is negative 1. Okay. We look up here, and indeed, negative xy and positive xy, sayonara. Positive x and negative x, those cancel each other out. That's kind of nice. We have an x squared. We have minus a y squared. Okay, so we've taken care of those two. So I'm going to say goodbye to both of those. I have plus y. That makes plus 2y. Those are gone now. I just have minus 1. I'm done. So that problem right there, I really apologize. I'm trying to hurry a little bit just for your time, but I should have wrote it and said, okay, you do this on your own. But anytime you see an example, it's nice to just pause it, try it, and then see if you can do it without us. We got one more thing to teach you in section 4.6. We're going to pause it real quick. All right. Alex and I are wrapping this up for you. So in 4.5 and 4.6, you'll notice there's some every other odd, and we're breaking up stuff. We're trying not to give you, too much to do, but enough to practice appropriately so that you learn the concepts. Some people are like, this is busy work, but definitely in any sport you play, anything you do, there's a certain amount of repetition that you're like, okay, I get it. But here's the deal. Section 4.6 is called special products. That's the name of the section. Now, there's nothing special about these products, okay? Product is the answer to a multiplication problem, but they're calling them special. They're all binomial times binomials, every single problem. But the first one, and this is the most important concept, and we must understand this, is that we just got done learning the power rule in the laws of exponents. And the power rule says that everything in the parentheses receives the exponent. So we had stuff like, 2x squared y over z to the third. And in fact, you could even bag that and just put this one monomial here, 2x squared y. If we took that all to the third power, everything in there receives the third power. That's not true with this one. We cannot say simply this is x squared plus 7 squared. Where here we can say, hey, this is 2 to the third, and x to the 2 times 3 is x to the 6, and y to the 1 times 3 is y to the third. That is the answer to this problem. Can we multiply that out and say 8? Yeah, sure, that's another option we could say, and that's true. But what I want you to understand here is that, remember, this is a shortcut. This is a shortcut that says I have 2x squared y times 2x squared y times 2x squared y. Okay, don't worry about this stuff up here, just look at this. And if we took all that, we have a mono times a mono times a mono, which would mean you'd have 2 times 2 times 2, x squared, x squared, x squared, y, y. And if we took 2 times 2 times 2, that would be 8. X squared, x squared, x squared, it would be x to the 2 plus 2 plus 2, which would be x to the 6th. Oh, look at that. And y to the 1, 1, 1, it'd be, y to the 1 plus 1 plus 1, which would be y to the 3rd. Look, these two answers are the same. Remember, all laws of exponents are shortcuts. We can take the long way to school and do it, but we like the shortcut. Notice this. If we don't take the shortcut here, we end up with x plus 7 times x plus 7. Agreed? What's a bi times a bi? Which means I have, x times x plus x times 7 plus 7 times x plus 7 times 7. X times x, x times 7, 7 times x, 7 times 7. X times x is x squared. X times 7, always put the number up front, 7x, plus 7x, plus 7 times 7 is 49. This ends up being x squared plus 14x plus 49. Notice that when we just brought the square to each one, took a shortcut, we were missing the 14x. No FUMAR. Don't smoke that dope. It's wrong. Don't do it. Okay? And that's the thing you got to understand. So here's what I'm going to teach you to help you always understand this. Why did the shortcut work here? Why didn't it work here? Here's the answer. Here's the key to success. How many terms are inside this parentheses? How many terms? Solamente uno. Only one. Only one. Because, look there's no plus or minus signs between. How many terms in this one? 2. The power rule only works on monomials, monos. It won't work on bis, tris. We can't take the shortcut. We have to multiply it out. And so you're going to see a lot of problems on the test and literally for the rest of your time in math. So what I want you to do right now, I want you to take just a second here, and I want you to take x plus 3 squared, and we're going to pause, and I want you to multiply it out, okay? All right, we're back. So hopefully you took this and said, hey, I'm not doing the shortcut. Brother Rich said, don't smoke that dope. So I got to say this is x plus 3 times x plus 3. So whenever you see this parentheses and it's being squared, break it up. Don't take the square to each one if it's more than one term and multiply it out. And we end up with x times x plus x times 3 plus 3 times x plus 3 times 3. We end up here with x squared plus 3x, number always goes in front, plus 3x, that's a plus, and plus 9. We get x squared plus 6x plus 9 for our final answer. If we had tried to take a shortcut, we would just say we'd have x squared plus 3 squared, which would be 9. And again, no FUMAR, don't smoke that dope, because we're missing the middle term, the 6x, if we don't go the long way on this. Okay, pause it for just a second. Okay, guys, again, one of the things they're gonna emphasize in section 4.6, and again, the directions are gonna say multiply mentally if possible. I say this in Canvas, I'm saying it to you on the video. Never do it in your head and don't write it out, okay? Don't try to, they're telling you these things because there's some tricks you can learn here. First of all, if you have something like this right here, notice that this equals, this right here, because we can't take the shortcut. And if we do this, we're always going to have x times x is x squared. You're going to have 7x plus 7x, and you're going to have 49 at the end. Notice that we got to that point there. That's doing a little bit of mental work. It's not showing all your work. You're not saying, hey, I got x times x, and x times 7, and 7 times x, and 7 times 7. You're like, well, I want to do it this way. Well, you got to show your work, okay? And then what's going to happen, these middle terms always combine. But notice that when these are the same, the middle terms are the same. And they just combine. And that's kind of easy. The other thing we talked about in 4.5 is this thing here, where the terms are the same, but one's being added and one's being subtracted. These are called conjugates. Okay, these are called binomial conjugates. Okay, so these are binomials, and they're called binomial conjugates. And the conjugate says, hey, I got the exact same terms, but one by they're being added, and 1 by they're being subtracted. So this by, times this by. And what happens is the middle terms always cancel out, okay? Well, one of the reasons they tell you to multiply mentally if possible is that, think about this, x times x is going to be x squared, and 7 times -7 is going to be -49, and if the middle terms cancel out, that's your answer and you're done. So let's just watch this. X times x, plus x times -7, plus 7 times x, plus 7 times -7. Indeed, x times x is x squared, number up front, minus 7x, number up front, plus 7x, and then we have minus 49. Indeed, these two terms cancel it out, and we're left with x squared minus 49. I like to see you show your work. You need to. I don't want you to just multiply those out in your head. You say, well, Brother Rich, why are you making us do that? Well, I'm a little older than you, and as you are very thorough in math and you always write things down. Listen, math is about accounting, and you can't account for something if you haven't written it down. And so you gotta write it all out and show your work. You have everything you need to successfully complete sections 4, 5, and 4, 6. Good luck. We'll see you next time.